Hello all, welcome to the System Thinking series. This video is about implementing a dummy login flow and inducing idea that could be leveraged while building an iOS application in real time. In order to get the best out of this video lecture, it is recommended to have some exposure to iOS and Swift language. The concept that would be covered in the code or we will be doing in action include separation of concern, constructor injection, unit testing, and abstraction with Swift protocol extension. Now let's delve into the overview of login flow. The login flow has two fields which takes a username and password and a button, the UI of which is actually depicted, and the high level class diagram talks about four different classes: presentation layer, domain layer, and data layer. In presentation layer, it has a login view and login view model. The login view will have a login view model. The login view model will have a login domain, and login domain will have a account data. The scope of unit testing is also depicted in the right side, where login view model validates if the login action on the domain is invoked, and on response if these states are updated. Login domain, on the other hand, has the business validation tool for the username and password, and it also checks if the data method has been invoked. The data, on the other hand, connects with the external network layer, which is potentially a black box, and it would send the request with username and password and get the response back. This image depicts the asset relationship that we narrated earlier. Now let's do a deep dive into the code. The boilerplate code that represents the login page is already written. It is written in SwiftUI. It has two text fields with a button action. The view model and state is defined, which is initialized by the constructor, and the state is actually an instance of login view model. Login view model skeleton, which has the state initialized and the function defined is also there, and the login state, which has the username and password, is also defined. The invocation of the view model function is done. As part of this project, a convenience method to call the network is written, which has configured with local URL, which returns username, which returns response for username and password. In actual project, this will be an actual network layer, but given that the scope is not to define the networking stack or to look into the networking stack, we are not focusing on that. We start with adding the data layer, and the data layer is actually the account data class, right? So we'll create a Swift file. We'll define the class account data. Why the name account data? So have you ever thought of it? So the idea of account data is that in the context of login, account data's responsibilities look into login, sign up, anything that has to do with the account details or the profile of the user. So that's why it is called as account. Login is one of the function, and this is particularly with respect to the data layer of the feature. Okay, now we'll move on to defining the login function. In the login function, we are defining the username and password with a callback. We can actually implement uh, different ways to return response, right? Callback is one of the means. We can use of async await. We can use delegation pattern. But in this context, any consumer of account data, once the processing is done inside the login method, would get a callback in return. We are defining a struct login response data, which will be the parsed representation of the data returned by the service. So the login service returns status and dictionary, which has key value pairs in form of the login's session ID. Okay, now we'll move on to the implementation. URL session dot shared, and we are calling the demo login endpoint method. We pass in the username and password, and we'll get the callback. We define the closure with the status and data. Inside this, we will be defining the condition where if the status is true, which signifies the service is successful, and if it has a valid data, we would get a success response from the login API call. If not, we will call the callback in the else case with the status false and data null. Yeah. So yeah, data needs to be parsed. Right now, the data that we'll get will be in the form of the data object. We'll have to parse it into the dictionary, right? So we are using the JSON serialization to convert the data into dictionary, and yeah, we'll pass the method with the data returned, and we'll cast it to the string. The contracts are defined, so now checking that as well. Yeah, now that the implementation of login is done, the login method, right, which uses an URL session. Okay, that escaping was missing because not this is an escaping portion. We should mark this with escaping. Cool. Now the question is, what is the problem that you see, or from an architectural point of view, is there any drawback with this approach? How can we make this better? Take a moment to pause the video and think. Once you're back, we'll look into the problem areas. The URL session in the previous class is tightly coupled. The behavior of the network now defines the unit test execution, and the test result would be non-deterministic. The positive and the negative test case would be difficult to be synchronized with the unit test execution, as the network behavior may vary time to time. How can we make this better? What's the solution for this? The solution would be to use constructor injection, where we inject the URL session dependency. And in addition to this, rather than directly using URL session, we will be using an abstraction, which is account endpoint protocol, wherein the tight coupling between URL session is removed. Also, the behavior of how the data task method could be controlled for test versus actual production implementation. Let's look at the code for the solution. So we are going to define the protocol. Data endpoint protocol. Yeah. It is a simple protocol with a method. So we are taking the down demo login endpoint invocation. Ideally, this would be replaced in production with the network layer method. But right now, since this is the dummy method that is being used, that's the definition that we'll add in the protocol. We're going to define the URL session. So this is an example of or the implementation of constructor injection. We just wanted to show how it would be to use a URL session. Now we are trying to replace it with the protocol, account data endpoint protocol. Now, once that is done, instead of in the place where the place where URL session was used, we will be replacing with endpoint. Now, rest all would remain the same. Now let's add the unit test case for account data. Let's create it in the test target. The account data test will have the system under test, which is the account data. We'll import the test target, which is the concept of the project name is given as such, to instantiate the account data. There is some mistake. Okay. This is, I mean, yeah, okay. Yeah, the problem is actually the account data, the name that we have given for the test class, right? That's conflicting. So we'll have to rename that. We rename it to account data test. This was a mistake. We did that. Now, yes, we'll be able to refer. Okay. Now, account data requires an endpoint, which, as we said, is a protocol that we have defined. As part of testing, we will not be passing the URL session directly. Instead, we will be creating a mock object, right? So, in order to create a mock object, we create new group mocks. This can host all the mocks that would be commonly used across the test target. We define new Swift file, mock account data endpoint protocol, class mock account data endpoint protocol. It could follow the it could implement the account data endpoint protocol. We have to import the concept target as well, so that the protocol defined would be visible. Now we'll have to implement the test logic. So that there is a little bit of boilerplate involved. Right? This is a necessary evil. However, there are different frameworks out there that would help or make this process easy. Right? But as part of this session, we are doing this manually. We are writing boilerplate code manually. So let's define a variable which is behavior mm, behavior flag. Yeah, it's a bool. So the intent of this flag is to tell what should be the behavior of the demo login endpoint information. So if the behavior flag is true, the side effect that would be created would be to return an error. Yeah, and that would mean to have to call back with the bool as false and data as null. Yeah, I'm writing the data here. Yeah, it's a string. Okay, status session ID login. This is a mock data. Yeah, given that it should follow the contract. Yeah, so I've changed the error, and once the behavior flag is false, we should not execute. Call that true. We pass data, right? Okay. So the mock method is set. Oops, there is an error. Okay. We name the file. Okay. Yeah. Let's add two more variables to capture the username and the password that is coming to the method. Go to username. This can be used during the unit test to compare what is been passed and what is that is being captured to the calling function. So it's more towards checking input. Yeah, there is an error. There is the data doesn't have a initializer that takes dictionary. We'll have to, yeah, convert dictionary using JSON serialize JSON serialization. Mm, yeah, with JSON object. Okay, so we will be passing the dictionary into the data with JSON object, and options are empty. So that's it. We can change this to let. Our mock object is ready. So yeah, now this boilerplate code is necessary evil, but yeah, this can be made easy with, as I said, some libraries, right? The intent of making the network deterministic is now achieved. Now we can very well use this object. We will define mock endpoint where we initialize in the setup method, and yeah, and we would pass the open part before that. And tear down, we are making it nil. We'll open up the assistant editor. This is a practice where having the class side by side to define the test case. Typically in PPT, you would write the test first and try to add the implementation. Here we have found the route that is opposite to it, but let's write the first test case. Okay, corrected the mark endpoint. So the test would be to test if the login method when success returns status and data, right? So yeah, now this data given that we have passed mock would be the one that we have defined in the mock class. So set system on a test and login method. Let's define or let's set up the inputs, right? Username, it's using test 1 2 3. Password, test pass. These are some dummy names and string. But in order to check the test, the response data we call back is configured. Now let's write the assert. Okay. Okay. Now the use of behavior flag, right? So mock endpoint dot behavior, yeah, flag is false. So what it means is that the mock endpoint will not throw an error, rather it will always throw success. So when we call login, which calls the mock inside, it will always be successful. Let's see assert 2. If the login is success, we should get response data to status to be true, which is our first assertion, and the expression, right? Now we are checking the data. We are copying because this is what we would be getting, we would be expecting. So the idea of validating this dictionary is to prevent any error due to unnecessary tampering with the code. So there could be refactoring that could be done after some point of time. So let's say if someone comments the code that invokes the endpoint method, right, or if there is some processing done, these tests would capture that. That's the intent. With a bit of beautification that we are doing, pretty much from a readability point of view. So run that. Uh, yeah, the setup should go above, right? Yeah. So because the error behavior flag should be set before the invocation. Um, it is set by default false, but still from a completion point of view, we are setting that here. Again, one more assertion that we can do here is the username that we have passed as part of the account data login method, is that reaching correctly, right? So we would be validating that. So the funny part is that There has been a production bug where username and password, the variable or the assignment got interchanged. So in the lower environment, it was working fine because lower environment never implemented the validation of password. But the moment the product got deployed, it was not working. So I mean, this is one of the experience. We'll run the test now. Build succeeded. Yeah. Wait for the error. Okay. Okay. It has failed right now. What has happened? Okay. Then we said this we'll follow TDD, but I think we said that we have written the implementation first, but I think red green concept is hitting us now. So we are checking the logs, right? So okay. Mm, this mock looks good. It's true. Account detail point of view. That also looks good. The test point of view. Let's look at the implementation. Status, data. Oops, yeah, this is the error, right? If the status is true and if the data, if the API is successful, we should return success. So our logic is wrong. No test has passed, right? Great. So we have covered the positive flow for the login method. Let's try the negative flow. Test if login failure. The assertion would be similar, but they will, since we have already tested some of the assertions like validating the username passed is reaching the dependency, we may not redo that. Rather, what we'll check is if the failure happens for the endpoint, does it give a callback with data as null and the status as false. So these are the two assertions. So response rate may not be required here. Yeah, error behavior, right? We'll have to set that as true because we are expecting the mock endpoint to return an error. Now that we have set that, we'll copy the invocation and instead of the assertion where status is true, we'll check it is false and the data would be nil. Yes, so nil. Yeah, response data dot data. Pretty much, we have done the negative flow also. Let's run it. Yes, executed successfully. Let's run one final time. Then that is suit. Sorry, test is for the right class. Both is executed successfully. So pretty much we have covered the test required for the account data. Mm, so yeah, so account data has been covered. Now the question would be, how Thus, you'll be able to write the test if you didn't have the protocol. Like if you are trying to write directly using URL session, would that be this easy? This is a question to ponder and do try it out. It will be quite difficult to even control the behavior of URL session uh, because the implementation is not exposed to us. In short, till the point that we have discussed, we were able to write test for account data without depending on URL session, and we were able to control the behavior deterministically to write positive and negative scenarios. Now, let us look next into how can we use account data, how can we implement account data to be production ready by the consumer. So a login domain would be consuming account data. Cool. Let's clean up a little bit. Now the account data endpoint protocol. So what we would do is that we would create an extension. In the current context, we would create extension for URL session, extending the account data endpoint. And given the account data endpoint or the method defined in that is already defined in URL session, things would work out very fine. So this is one of the means in which we can extend or conform to a protocol and leverage it as a abstraction. Now we have defined domain and the group login and the login domain class. Find the file, and after that the class. Let us define the methods inside it. Validate function, which takes in the input, and the idea is to validate any business rules for the input, right? We will not implement the business rules, rather we will return hard-coded true. But in ideal or actual case, the business rule that is defined in the context of domain to be implemented here. Okay, so we would validate username and password. Now let's implement the domain method for login. The signature would be similar. Okay. Let's make it a little more cleaner, right? We call the group of username and password as login input instead of from a readability point of view. Right? Input output is a convention. You pass in an input to a function, the response comes as an output. Here also the callback is being used. We are actually defining another struct that could be the response to the consumer of the login domain. This ideally would be the login view model. Callback, we are returning the login data, login response data. Okay. And yeah, okay. Now we have the account data reference. We will use the constructor injection here. We are making this private uh, and implementation of login, validate using. We are changing it to one method instead of two, right? takes login input, validate input, login thread, else return, and the callback. Login response, the error status is true, the error message is valid inputs, and account data, login thread, and the callback. Okay. Once the callback is okay, now we are this doesn't look cleaner because if it is propagating a callback from a readability perspective, modern Swift has introduced acid weight kind of a mechanism that gives a better readability. You can even use reactive programming where combine. We have it using callback in this context. Continue with that, and we are giving the callback where we are sending the status error message. Right, if the status is true, we don't have another error message, and the token for successful login. So if the data returned is nil, the token would be nil. So that's how it is. Okay, let's define it into a variable response and wait. So we have passed into the callback. Okay, escaping. Okay, that also is corrected. Pretty much that's it. Yeah, using string or magic string as the pattern in production ready code, we would not go with using direct strings, or even for that matter, the data that is sent from the account endpoint, right? That will not be in the form of dictionary. Ideally, that will be converted into some form of data objects via codable. It's more towards making the code that we have written type safe. The faster we find out any error, or faster we hit some error, we lesser the cost of correcting it. Yeah, so that's the idea. Now, if you look at the login domain as well, the account data is tightly coupled to login domain. So the route where we define an abstraction for your session will follow a similar approach where we would create, an account uh, data protocol. So we did the refactoring, new file account data protocol. Uh, so we are exposing from the data there only those things which are necessary for the domain. So in the account data, we use account data protocol. That's it, right? The account data protocol has the method login domain user. So everything works well. We are instantiating, which is default constructor. Default account data with an endpoint. So now account data is also using the extension. That's it. Now let's focus on the test. Did, we did some cleanup. We have done. We have created the domain test. We did the boilerplate of folder organization as a separate topic to see typically the mocks that is used throughout the test target or the covered mocks is what would be written as part of a separate folder. Otherwise, the practice would be to have the mocks directly, or if the usage is minimal to only the particular test, it would be better to have it as a private implementation within the test file so that it will be easy to manage. Otherwise, too much files in a larger project, it is quite tedious. Yeah, and that's a logical, or that's a team decision that you can take while you are in a project. So mock data, which has a similar implementation, to do that. Yeah, so we have to implement the login method similar to what we did for the test while we wrote for the count data. Right. So similarly, we have to do that. So the idea is to mock the behavior, and the dependency would create a deterministic, mock account data, right? So in case of unit test, as we said in the earlier slide, right, we would not worry about anything beyond the system under test. So login domain is the only functionality that you'll be looking at, and the positive and negative scenario based on the data returned from the mock account data is the point of interest. And other thing would be the business tool, which is an additional function returned for the validation, that which is actually in the scope of the login domain that which would be tested. We will not be delving into the details. We'll move on to the implementation of login view model where login domain has been consumed. So we are initializing in the constructor, then calling the method, passing the input, which is the state that is written by the UI, and the response is true. We would handle the login response. Yeah, we have yeah, written a private function to make it readable, separating the responsibility into smaller functions. Sets a state and takes a state. Will not be implementing and showcasing the UI, rather just to connect with the explanation. We are writing the placeholder functions. Uh, there will be, like, in the success state, there could be possibility of saving token or you're navigating next screen, and in error case it would be showing some alerts or indicators that the login has failed. The actual implementation could be a self-paced exercise that can be done by the audience. Now that we have reached the end of the session, I wanted to make some callouts before we conclude. For production implementation, the data class will not directly use URL session object. We had conveyed this earlier that there will be a network manager or network layer. There should be some form of abstraction. That's pretty much the same. The scope of the video is planned to cover presentation domain and data layer, extensively looking into the other parts that would come in a production ready application. It's not planned. It could be potentially a later session. Further call out include the usage of extension to create an abstraction for a class which is a black box. The name and suffix uh, that is to relate the responsibility of the classes. In reality, these may not be the actual names used in production. There are some patterns like using of explicitly unwrapped option, which is not used in a production ready app. We will move on to the recap of some of the behind the scene concepts, starting with unit test, followed by suppression of concern, constructor injection, and the protocol extension. The snippets of the code usage and some high level points that would help you to recollect is depicted in these slides. I hope this session would help. Thank you for listening patiently.